Any questions for me on the lab work? Wow, got a celebrity here today. Rare sightings. Any question on the lab work? 13, 14? I mean, yeah, 13, 14. Nothing? Not many left. Because today is the last lesson of the semester. Huh? At 6 p.m. Last lesson of this class, of this semester. You hear me preach no more. Besides review, yeah. And answering your questions. We ready? All right. So today, we're talking about exponential growth and decay. Exponential growth and decay. The formula for exponential growth and decay is this right here. This formula should look very familiar to you. It looks very much like this formula here. Right? So with that, we know that A is your final amount. A sub 0 is your initial amount. T is still your time in years. And K would be your rate, which is still in decimals. Well, of course, your question is, wait a minute, then why use a different looking formula? It's the same freaking formula, right? Why use K instead of R? Well, the top equation is for banking, for financial, right? The bottom one is more scientific, biology, chemistry, right? Where K, if K was positive, then we have growth. If K was negative, then we have decay. Which, financially speaking, we never want to have a decay. Hopefully not. It goes up and down, but hopefully down the road, it's all growth. Hopefully. Fingers crossed. Okay? Any questions there? Pretty easy? No problems? So here's the question. Let's go ahead and give you these things here. Is the k going to be positive or negative? No idea? He says negative. Anybody else? Would you like him to explain why it's negative? Why is it negative?
Because the initial amount is greater than the final amount.
So if I started with $51.20 and I ended with $36.04, did I decay or did I grow? Decayed. So that's why it's going to be negative. Does that make sense? Okay. Let's plug it into the formula and see if you guys can find what k comes out to be. I think ChatGPT is still a better translator. Oh. Did we all figure it out? That's what he got, so it must be right. No? Yes, you do. You do know how to do it. Stuck as well, huh? Okay. For whoever is stuck, let me give you a sample of what you might think of. Okay? What if this was what if that was the problem? What would you do first? You definitely would not square both sides. Wouldn't you isolate the square root by itself? Wouldn't you do that and then square both sides? So you will isolate the square root because you know the opposite operation of square root is a squared. Make sense? So we would do exactly the same thing here. We want to isolate the e. So now we got to say, what is the opposite operation of E? Which is ln. So you would take the ln of this side, which means you got to take the ln of this side. I would. I would. Yes? I know. So here is the good, bad news on that. This is a really bad example for that. If you want to use more decimal places, then you can get to the right answer. If you don't use enough decimal places, 9 times out of 10, you'll get the wrong answer. That's why I would leave it this way. So I would say that is it 0024 or 024? No, it's 024. Yeah. Is there 0.024? Does that make sense?
Yeah.
So we're going to isolate the thing that we know the opposite operation of, right? Because the ln and the e would cancel each other out. So that's why we'll only have left the 14k.
ln. E is also. Yeah.
We okay? Are we okay here? Does that all make sense? So I don't know if you guys remember this, but in the very beginning of these lessons, many pages ago, remember when we did compound interest? And then we did an example, and I continue to say, hey, this is what's going to happen, right? Yes, maybe we have to find the initial amount. That one's easy, right? We just get this, divide it off, and we got it. But then we also got to find maybe the rate or the time, which is an exponent. These two here we won't be able to do until towards the end of the unit. That's what we're talking about now.
Rate or time have to be exponents.
It's going to be exponents, so we're going to have to find those, right? But the good news is that it's e, so that means we isolate the e and take the ln on both sides, just like we are right now. Just like what we did here, right? So, which is what your number 7 and number 8 on the lab work is about. It's the money equation, but you're looking for rate or time. Okay? Are we okay here? Any questions? Nothing. All right. So let's talk about half-life. What does half-life mean? What does that mean? So, huh? So, I have a sandwich here. Egg salad. Okay? If I said the half-life of this sandwich is 2 minutes, what does that mean? Huh? The half-life of this sandwich is 2 minutes. Huh? But what does a half-life mean? So the half-life means, if I said the half-life of this sandwich is 2 minutes, that means huh? Yes. It means that half of this sandwich would be gone in 2 minutes. The problem is this, though. The problem is this. If I go half-life, yes, in 2 minutes, half will be gone. The problem is that in the next 2 minutes, half of this would be gone. In the next 2 minutes, half of this would be gone. After 2 minutes, half of this would be gone. After 2 minutes, half of this would be gone. After 2 minutes, half of this would be gone. After 2 minutes, half of this would be gone. After 2 minutes, half of this would be gone. You're wondering how many 2 minutes I'm going to go through here. Well, we're getting close, right? So it doesn't really get to 0. So it's not about half of this sandwich is going to be gone in 2 minutes, but it also doesn't mean that in 4 minutes I'll finish the sandwich. Does that make sense? Okay, I only finished a quarter of it, and then an eighth of it, and then a 16th of it, and so on. So that's what half-life is. Okay, half of it goes away in that given amount of time. So let's say I start with a final amount, and the final amount in the equation is A, right? Again, I'm only using A. I'm not going to use the A sub 0. I'm using A. If the final amount is A, what would the initial amount be? Wouldn't we double the amount? Does that make sense? Does that make sense? If I start with 2A, in a given time, half of it will be gone, so I'll have an A left. Okay, let's go over here. Let's talk about the initial amount, A sub 0. If that was the initial amount, what will be the final amount? Half of that. Does that make sense? Okay. Let's plug both of those into this equation. Okay, let's start over here. Would you agree with me that I have A is equal to 2A e to the kt? This is equal here. I'm just using this equation. Plug in the final amount, plug in the initial amount. Okay? Would you agree with me that if I was to divide this side by 2A, that I would have to divide this side by 2A? So that means I have an equation that says 1/2 is equal to e to the kt. Agreed? Cool? Questions? Because the A is the same on both sides. So we're just getting it to the same side, but it happens out that it cancels out. It just happened to drop out. Yeah, it's not the fact I'm trying to get rid of it. Okay, let's plug the same. Let's plug this into the same equation. So let me see. The final amount is 1/2 A sub 0 is equal to A sub 0 e to the kt. I'm trying to derive or show you guys how to derive to a so-called formula here. So here, since I have A sub 0 on both sides, let's go ahead and divide both sides by A sub 0. Would you agree with me that I would have 1/2 equals e to the kt again? So what is these two formula really talking about? This is half-life. So notice that with the half-life formula, it doesn't matter if I have any amounts. There's no concern about amounts. Everybody see that? If you look at the half-life formula, it's about rate or time. Right? It doesn't say start with 1 sandwich and with half. It doesn't talk about that. Right? It doesn't matter because the half-life is about the rate or the time. So here's the thing. Most of these questions that you're going to be dealing with are two-parters. All right? Meaning, if it says half-life, you're like, woo, half-life formula. If it gives me rate, I want to find time. It gives me time, I want to find rate. That's part one. Part two is once I find the other, I'm applying it to the next part of the question. Is that fair? So let's do a problem that will involve half-life. So example. Silicon-32 has a half-life of 710 years. If 17 grams is present today, how much will be present in 300 years? Is it going to be more than half or less than half? Yes, you do. You know that. So half-life is 710 years. So if I have 17 grams, that means in 710 years, it will be down to 8.5. Yes? But my question is, after 300 years, I'm going to have more than half left, right? Does that make sense? Right? Because it takes 710 years to make it in half. It's not getting anywhere close to that. It was only half of that, so chances are I'm going to have a lot more. Okay? So you got that part got to make sense in your brain. So when you calculate it, you're like, got it. Right? Anybody want to tell me what the first part of this problem is going to be? Well, actually, before I ask that question, does the 32 have anything to do with this problem? No. It's just that element. Silicon-32 is just the element. See that right there? What's that word? Oops. So if it says half-life, it might have to do with something like this. Is that right? Because I just mentioned that if it says half-life, we should think this, right? So just maybe, if it since it mentioned half-life, that I should just think about that piece. Agreed? It mentioned half-life. So half-life, we're going to think about this right here. So do you think I have K or do I have T? I have T because it says 710 years. Okay. Seems pretty simple, right? So I'm going to say 1/2 equals e to the k times 710. So in other words, ln of 1/2 is going to equal to 710 k. So that means k, or ln of 1/2 divided by 710 equals k. Is that true? Because what's the opposite operation of e? So for anybody that missed what I just did, since I know the opposite operation of e, which is ln, make sense? Do I care about this number right now? Don't care. I'm going to leave the rate as that. Just going to leave it. That's my rate. For the first part. Guess what my second part is going to be? The rest. Let's see if we can answer this question. What formula do you guys think I need to use for the second part? Guys, how many equations did I give you so far today?
The other one, exponential.
We used one. What do you think the other one's going to be? Oh my goodness. I only gave you 2 equations, guys. Now, there is a chance that I might have to use this same equation twice. Half-life, I use half-life, and then use this equation, since there's only 2 equations. All right. What's my final amount? Hopefully that's what you're looking for. What's my initial amount? Ta-da! And just plug that into your calculator. Don't plug in your Apple calculator. Use Desmos or use your TI. Because this is what I love about Desmos. Because it looks like that. It looks exactly the way it was supposed to be entered. Well, the graphing will show the same thing. The graphing you can do. Same exact way. Questions? None? None whatsoever. Did you want to see this? You did. You didn't use e raised to the power. You did e times. And it's approximately 12.68 years. I mean, grams. Yeah, that's it. That's the ticket. That's it. Let's talk about this. Because I'm sure you guys are going to have a question about it. So everybody got 1 through 6 done already, right?
Yeah.
Because that's all review. Seven and 8, you're just finding time, solving for time, right? Number 10. Let's look at number 10. Number 10 is saying, it's talking about a species of fish that is decaying. Huh? Well, no, because it won't, because it's 30 grams. So very close. So number 9 is saying that a fish population is decreasing exponentially. Okay? So it's saying 9 years ago, there was 1,500 fish. Today, there's 1,000 fish. The problem is that if this fish population goes below 100, we can't reverse the process. The fish will go extinct. So the question is, when in the future, will the fish hit 100 fishes? Left. Does that make sense? So that's why it's 2 parts, because the first part is, I know the time that this has been decreasing. So that means I got to find the rate that's decreasing. I'll apply that same rate to part 2. So I can find the years. Make sense? So that's the 2 parts. Part 1, part 2. So this way I know, as a scientist, how many years I have to find a solution for this before it goes extinct. Okay? So that's number 10. Scientist. And yes, you're going to probably use the same equation for both parts. Because this doesn't say half-life, right? So don't use half-life. Just like in this lab work, people started putting change of base rule in here. Have we ever used change of base in condensing and expanding? Then why is there a change of base? Oh, because it doesn't belong in there. Why is there a way of converting exponent form to log form and log form to exponent form? Is that ever applied in condensing and expanding? No. Correct. Good job. Hyperventilate, no, same answer. Okay? I don't mind you guys putting too much, but when you're putting nonsense in there, it becomes nonsense.
What question was that?
Number 5, if you would have checked the Canvas message, it would have already been posted. Huh?
I thought your cues were 8 when you posted it. Almost had an aneurysm. I was like, no.
I hope my 8s look better than those.
Well, I can't see that well.
I hope my 8s look better than that.
And my phone's on crap too.
Someone said something else about them too, but not 8s. They thought it was something totally different. They thought they were like, I can't remember what it is, like Z's or something like that.
I could see that. The cursive Z.
Yeah. But I thought my 8s would be better than that though. I have to have an 8 somewhere. Ah, there it is. My 8 would look something more like that. But I can see it. I can see it. I can see it. But there's no 8 in the problem. I understand. So any other questions? You know what, I gotta say though, you guys helped me a lot in terms of knowing what I need to do in the beginning of the semesters. Like, beginning of next semester, it's gonna be like, the first day is not gonna be talking about the syllabus whatsoever. It's gonna be like, all right, everybody, we're gonna connect you to the correct Wi-Fi. And then we're gonna download Desmos and OneDrive. And we're gonna scan right now. And we're going to submit it as lab work 1 right now. Like, I feel like I have to hold the hands because people have been telling me, well, the first week I was struggling with scanning. I'm like, really? All right. I guess I'm, huh? But it was like the first, like, it was like the second week before I did that. Yeah, it was like the second week. So that's why I got to do like the first day. It's just like, okay, we're gonna download all these things, and then the second day I'm gonna have to be like, okay, I want to like teach a problem, like teach my lesson, and then go on the lab work and say, okay, let's use AI now. Let's use chat. Let's scan this in. Does this work look like what I put in the notes? No. Okay. Now let's kind of pull the notes into this problem. And then going, give me general guidelines. Okay, does that look like the steps I gave you? No? Okay, what did my steps look like? Let's put those in there. What are the other possibilities that could happen in this problem? Like, I feel like I need to do that. Well, I think that the biggest struggles for most of you guys has been what? Knowing what the heck to put down. Right? There's a few of you guys that go, I got it. Like, he really wants the variety. Like, expanding and condensing, right? Even though if this problem is about condensing, he wants the expanding part because that would be similar to this problem. That's what I'm saying. Like some people made the connection, some people didn't. So that's why I was like, okay, in the first week I got to talk about all of those things to connect them so that they could understand that it's not just about the one side, but what is the possibilities that can happen. And maybe even talk about, let's do the whole lab work, and let's say which ones are similar. What varieties were in there, and let's talk about that into what we know, and then just post the same what we know for all of these problems. So that's, like I said, you guys have helped me quite a lot. So, and ladies and gentlemen, with that being said, guess what? Welcome to the last lesson of the semester. So, I have two things I got to bring up to you. One, in your MLM, Pearson, there is a last assignment. That last assignment is called the review for the final exam. It's not my review for the final exam, so that is not optional. It is for a grade. Yep. And it is 70 questions. So, this is the reason why I'm bringing this up. This is why I'm bringing it up, because I want you guys to be proactive here. Meaning, what I would like you guys to do is open up that assignment and look for all the Chapter 4 assignments or problems and do those problems, because that will help you with this exam. After that, every single day, class and non-class days, do 3 to 4 problems every single day. The part that sucks is the fact that when you do 3 out of 70 problems, the grade's going to suck, which is going to affect your average. But you need to trust the fact that as you're doing 3 to 4 every single day, that is going to go up and your average will go up. The only thing that is not going to go up is if you stop doing it. Right? Make sense? The reason why I'm having you guys do this is because when it gets to the due date, you might only have 3 to 5 problems left rather than 70 problems left.
That's just like your way. We don't have to do 3 to 4 like if we want to do it.
If you want to do it all, go for it. I just don't want it to be like the last day and you're like, oh crap, I got 70 problems to do. And I got history to study for, I got this class to study, you know what I'm saying? I got final project to hand in, I got a presentation, I got 70 problems to do, right? Yep. Yes. Yep. Second. SOS opened up yesterday. The student opinion survey opened up yesterday. If you haven't checked your school email, it's on the left-hand side that says SOS student opinion survey. You click on that, you can take the student opinion survey for every single one of your classes. Okay? Some of your teachers will actually give you extra credit for doing it. But you already know me, don't give extra credit. However, I still think that mine is better. So let's say I tell you, I'm going to give you extra credit. I'm going to give you 10 points on your homework assignments. Okay? Watch. The problem is that the 10 points on your assignment is only 10% of your grade. So it's a whopping 1 point. But here's the thing. After exam 4, I'm going to bring it up again. I'm going to bring it up during the exam as well. I'm going to send you guys a message. But after exam 4, I'm going to bring it up again. I'm going to give it a deadline. And then if 70% of the class participate in it, I'll reopen up MLM. All of them. But the 70 question isn't due until the last day of school. I don't know. You got to look at MLM to look. It'll all open up. It already opened up twice. This will be the 3rd time it's opening up. Yeah. It's opened up twice already. This is the 3rd time. The whole spring break was open for the full week. So it will be after exam 4, but it needs to be 70% of the class participating for that to happen. Okay? Like I said, I'm going to let the whole class know during the day of the exam so that everybody hears it from me, and I'm also going to send the Canvas message about it. So, again, so the way I do it is this. So let's say I tell you it's that Sunday is the deadline, right? If you're at 70% or more, I'll open from Sunday to Saturday. But let's say at Sunday it doesn't get there, and then Tuesday it gets there, then it will open from Tuesday to that Saturday.
So when's the like deadline to hit the 70%?
I'm going to tell you just to get it done, just so that it's done, and then I'll apply the due date to it after that. Because then, if it wait too long and it was only Thursday you get there, it'll be only open from Thursday to Saturday. Yep. Participate.
By 70%, you mean like Mondays, Wednesdays, and us?
No. Just your class. It's based on class. So 70% of your class do it, your class opens up. Another class doesn't do it, they don't open up. Doing the SOS. Yep. Okay? And give me some good comments, boy. No. Again, I wouldn't get extra credit, would I? So if you give me good and bad comments, I'd still don't get extra credit. It's better, way better than extra credit. Trust me. All right, ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys Thursday. Later. Bring your review with you on Thursday. See ya. Bye-bye.